burn it as a infectious or biohazard product. Okay, the big thing in scope is to define your functional units. Okay, because when we look at it, it has to make sense. The functional units. Okay, the functional unit is the reference point where all inputs and outputs are measured. Okay, so example here, you make one package of sausage, then everything would be scaled to one package of sausage. That all the materials required, all the emission produced based on one package of the sausage. Okay? It provides standardized way to quantify the environmental impacts and allows comparison between two products. Okay? It should reflect the primary function of the products. Okay? According to ISO 14044. So for example, sausage is meant to be eaten, right? So it's based on one package of sausage or something. So example functional units: 1 liter of milk, right? 1 ton of steel, or 1 kilometer driven by car. Okay? And there are a bunch of functional units, right, of products for soda water. For like Coca-Cola, could be like based on the 1 can or 1 bottle, or maybe even based on the volume, like 100 milliliter or something. And then there's like detergent, the rice, condoms. Condoms comes in a box because it's sold as a box. So you don't do the functional unit as one single condom, right? There's a box of 3, so you do the carbon footprint for 3 pack of condoms. And then Slurpee has different size of cups, so you might do it based on the volume or something. Okay. And now there's a video, which is a good video. They're discussing how to define a functional unit. Okay. He'll be discussing coffee. Okay. What do you think is a good functional unit of coffee? What is functional unit of coffee if you want to do the carbon footprint? You drink coffee, right? There I see some thing called chocolate. Right? I don't drink coffee, so I have no idea. I'm very innocent. So what's the functional unit of coffee? So it could be by per container, right? Per cup, right? But then there are different kind of cup, right? Could be per volume, right? But then when I went to a training workshop, it said coffee, the main purpose is to give you caffeine. So you can do functional unit of based on the amount of caffeine, okay? But this one he will talk like about coffee in 3 different kind of cups. Let's watch it. Now my screen's blinking really hard. Time to buy a new one. I'm waiting for donation. Christmas coming. Black Friday is next month. Okay. Where is this? Functional unit. Is it this one? No, it's the other one. Functional unit, this is the latest one. Here, functional units in the reference flow. Okay? This is a good video, so it makes you think. Okay?
Hi again. Today we're talking about the functional unit and reference flow. When we compare 2 or more products that serve the same purpose, it is necessary that we clearly define what this purpose is in a measurable way. So for example, when we are comparing the disposable cup alternatives to the ceramic cup, the purpose of the product is to hold coffee. How do we quantify this? How much coffee are we talking about? The different cup alternatives may have different volumes, which is something to consider. Beyond the volume, and particularly from a life cycle perspective, surely it is important to consider that the ceramic cup can be used over and over again. In other words, the ceramic cup has a longer use phase and will ultimately hold way more coffee in its lifetime than a disposable cup. You might also be thinking to yourself, hey, wait a minute, although the ceramic cup will hold more coffee and will be used for longer, it needs to be washed repeatedly. How does all that water and soap to wash the cup compare to a disposable plastic cup or a disposable paper cup, which doesn't need to be washed? And what about all the plastic or paper waste per cup volume for the disposable cups? If you are already thinking along these lines, then you are well on your way to becoming an LCA practitioner. Coming back to the question of quantifying the purpose of the cup, in LCA we use a functional unit to facilitate such comparisons. That's the key word. Give me some jazz. Functional unit. A functional unit is a measure of the function or purpose of the product. In performing an LCA, we as the practitioners decide what the most appropriate functional unit will be. The functional unit should serve as a reference according to which all the environmental exchanges or inputs within our system boundaries can be scaled. Coming back to our coffee cup example, let's say that our functional unit is 200 ml of coffee served. We can then compare our disposable plastic cup, our disposable paper cup, and our ceramic cup according to this functional unit. But how do we account for the fact that the plastic and paper cups are disposable and the fact that the ceramic cup is reusable? Since the ceramic cup will be used over and over again, let's say 1,000 times, we will need to divide the total inputs for the ceramic cup in our product system by the number of cups served in its lifetime. In other words, we need to scale our ceramic cup inputs to the functional unit of 200 ml of coffee served. Okay, so what about the differences in volumes between the cups? I hear you ask. If each cup holds a different volume, then we need to adjust the factor by which we multiply the inputs. What we end up with is a separate reference flow for each of the products that we compare. Another key word. Give me some jazz. Reference flow. A reference flow is the quantity of the specific product alternative that we need to be able to fulfill the functional unit. So, let's look at this example more closely. We have a disposable plastic cup of 150 ml, used once, a reusable ceramic cup of 250 ml, used 1,000 times, and a disposable paper cup of 200 ml, used once. If our functional unit is 200 ml of coffee served, then we will scale all the inputs for each alternative accordingly. We multiply by 1.33 for the disposable plastic cup to go from 150 ml to 200 ml. We multiply by 0.8 to go from 250 ml to 200 ml for our ceramic cup. But don't forget, the ceramic cup will be used 1,000 times. So we also need to divide by 1,000, or in other words, multiply all inputs by 0.0008. Finally, the disposable cup, paper cup, is multiplied by 1. At this point, you should realize that life cycle assessment is completely linear. So what do we mean by linear? Linearity in LCA means two things. First, LCA is linear in the sense that we can proportionally scale the reference flows without considering non-linear phenomena such as economies of scale. In fact, LCA was designed this way to make comparisons between different products easy to apply. LCA is linear in another sense as well. And this comes back to how the life of the product is considered. The product system we consider starts from the processes that are necessary to create the product in the first place through to the product's end of life or disposal. In other words, from cradle to grave. In this sense, life cycle assessment is not circular or cyclic, but rather a line from beginning to end. It's linear. So then the question is, how does it fit into the concept of circular economy? Later on, we will look at how LCA can be applied to circular products, but first we need to understand the basics. As a thought experiment, try to identify a product that you use on a daily basis, like a coffee cup example. If you had to compare your product to an alternative product that serves the same purpose, then what would the functional unit be? Think about different types of light bulbs, perhaps, or even sources of light, like candles or lanterns. The question is then, what would be the appropriate functional unit? What is the functional unit of the product you want to compare? So to conclude, do you still remember the key words for this clip? Functional unit and reference flow.
Okay, maybe I should have that music too, so that you anyway, so I think what he discussed is that he wants to compare 3 different types of coffee containers, right? But then to make it fair game, he said the functional unit to be like the 200 mils of coffee served, and then they will scale all the numbers according to the volume of each container. Okay, and that for the ceramic one, they also divided by the number of time used. Okay, so keep that in mind in the future when you try to calculate the carbon footprint. You need to define the functional unit for your process, for your product, not your process. Okay, so we go through goal and scope, and like the functional units, the system boundary, the functional units, and then the assumptions and limitations. Okay, assumptions are what we assume for our calculation. Okay, so it's some simplifications or generalization that you make during data collection. Okay, for example, you assume a certain mix of like different sources when they make the electricity. I think Thailand has a number, right? It will be, I don't know, 40% natural gas, like 10% solar or something. Okay, but we have a mix. Okay, so we will say like, oh, okay, let's use this average number for calculation of like electricity emission. Then you state that in your report. And limitations. Okay, so you might need to exclude something from the calculation. This is not what they liked, and that this is not what you should try to do. But unless it's really necessary, then you have to say that why. You have to explain why. Okay. Okay, example, goal and scope for product. Okay, so the goal is to assess the carbon footprint of single-use plastic bottle and compare it to a reusable glass bottle. Okay, so you assess the plastic bottle carbon footprint and you compare it to a reusable glass bottle. Okay, then you can see like which one is better. Okay, the system barriers are cradle to grave. So from raw material extraction to production, to distribution, to usage, and to disposal. Functional unit would be 1 liter of beverage package. Okay, so the bottle package, the package should hold 1 liter. Okay, so but you can scale to different size. Okay, assumption, average disposal rates or recycling percentage. There will be a number. Okay, for like for plastic bottle, there will be a number of percentage of bottles getting recycled. Could be for Thailand or something. For Thailand, it's a bit low. Okay, and then how much waste we throw away, and the distribution of each waste. Okay. We can obtain this number. Okay, and the boundary focus on North American market. Okay. But we usually focus on Thailand, right? So next step is to create the life cycle flow. Okay, life cycle flow. So life cycle flow is visual representation of various stages of the product. Okay, so we come from raw material extraction, manufacturing, transportation, use, and end of life. Okay, and all these things will have some input and output. Okay, Inputs, usually resource or energy use. Okay? The process then will be transformed of input to output. Output usually products, byproducts, and some waste and some emission. Then the boundaries, we already talked about the boundaries. For extraction, so it involves like getting the raw materials from nature, such as mining or mining for metals or some ores, and then harvesting the crops, right? Input will be natural resources, output will be raw materials and emission that raw materials that we can use in our process, emission that we need to account for in calculating the carbon footprint. Okay. Then for manufacturing, we transforming the raw materials to finished products. So input includes like energy, raw materials, and water. Okay. Process involved like refining, assembling, packaging. So we account for all of that. And output will be the products, some waste, some emissions. So input and output are similar. Right? So all this process they are similar. Then we go to distribution and transportation. Input will be the fuel or energy that used to drive the products around. Okay, it depends. Could be diesel, could be gasoline, could be biodiesel, could be whatever, could be electric, right? Process about shipping, trucking, or flying of the products to the destination. Could be the distribution point or the retail distribution center or retail points. Okay? Output will be the product delivery, the delivery related emission. Okay? Then for the use phase, okay, we include the energy, electricity or fuel. The process is like for example, driving a car using a smartphone. The outputs emission and waste during the product lifespan. The end of life. End of life is either dispose or recycle. Okay, if you dispose, it depends on how you dispose the product. Landfill or incineration, right? If you recycle, that one has no emission, right? Recycle, you get free pass. Recycle has no emission, okay? So those are the product flow. And then the main point of doing the carbon footprint is data collection, which is the toughest part of the process, okay? Two types of data, okay? Primary data, this one you collected yourself from the company, okay? So it's actually the actual data from the actual site, okay? Includes process data, for example, direct emissions, so you measure how much CO2 was emitted from the flue. Energy use, you have the electricity meter attached to the process of the plant, right? And physical data. For example, you can measure the waste that's produced, how much waste in kilograms is produced, how much weight of the product you produce, or how many units, right? And data is collected and owned by the reporting organization by the company. And usually they collect this for at least 1 year. Okay? So if you're gonna do a proper carbon footprint, you go to the company every day, collect for 1 year. Okay? So that is a long time. Okay? So, but that is what everybody prefers, the primary data. Okay? The secondary data is only when the primary data is unavailable. Okay? Derived from source like the database of life cycle analysis, industrial average, and then sometimes extrapolated from similar system. Okay? Means like maybe you have a similar system somewhere else, then but it's different in the capacity or the production, then you do some kind of calculation. Okay, come back for primary data. You need to collect the energy consumption, the material usage, and the emissions by measurement. Okay, this is necessary for the process at deemed hotspot. Okay, so if there is a process that gonna emit a lot of greenhouse gas, then you need primary data on that. Okay, it's crucial for an accurate LCA because it reflects the actual operation of the company. Because you cannot do the assessment based on number from other sources. Okay, most of it must come from your actual workplace. Okay. For secondary data, this we already talked, so it comes from someplace else. So it's important to ensure accuracy and relevance of secondary data to avoid misleading conclusions. And then we also need to do quality control on the data. Okay, so we keep collecting the data. Even though if we finish, we might need to keep collecting the data and compare it to the number that we have from before to confirm that the number that we get is actually good. Okay, so it's not one-time task because we need to update all the time. To prepare for data collection, which is a big task, right? You define the scope of data collection, so you're going to do like a cradle to grave or cradle to gate, right? Prepare the process flow chart, say how many steps are in the process, which is the input, which is the output, right? Provide details for each production unit, okay? Then specify the measurement that we have to do and the unit that we use, okay? Provide details on data collection techniques and calculation techniques. Prepare the manual explaining how to provide the data and prepare the data survey forms. Why? Because sometimes we don't do it ourselves. We ask the foreman or the operator to collect it for us, right? But we have to be clear what they have to measure or what they have to collect so that we get the suitable number for our calculation later. Data required for the survey, production steps and related details, time period for data collection. Like I said, usually at least 12 months. Okay? Steps and method to obtain the data, quantity of the inputs and quantity of the outputs. Okay? So this is what they fill in the form. Okay? So we have process unit. We have raw materials coming in, product and byproduct or co-products coming out. Right? Inputs and inputs will be energy and water. Output will be air pollutant, water pollutant, solid waste. Okay? And then we measure all of this. Okay? We measure all of these. Process that need to be considered. So the actual manufacturing and packaging process. Okay? Packaging counts as well. Okay? Because you need to package things before you send out to retail, before you distribute, right? And then relevant supporting process. For example, energy generation. If you have like a local generator or you have a steam boiler in your company, right? Waste treatment, the internal transportation, water quality improvement, maintenance, cleaning. Yes? But maintenance, there will be some like a waste coming from maintenance, right? Some oil, some lubricants, something like that. And cleaning, like the guy said in the video, cleaning will release some surfactant, and that's a big contributor to your carbon footprint. And then operations in the company areas, not just the office, not just the factory, but include the warehouse and distribution center as well. Okay, so it's all It includes all the lighting, heating, air conditioning, ventilation, humidity control, and pollution control. So all the activities in all the buildings need to be accounted for. Okay? This will be repeated in CFO, the organization. Okay? Some activities that is exempt from the calculation, human energy. So if you go and do something by hand, no carbon dioxide emission. For example, you go pick fruits by hand, go to apple orchard by hand, pick to make apple juice. The hand picking part emits no CO2, okay, with exempt. Customer travel, so customer go to buy your product from 7-Eleven. That carbon emission during the travel doesn't count, okay? The capital goods, office, research and development, quality control and assurance process, it does not count, did not count. Employee commuting to and from work, this one is not counted here for CFP, but it will be counted for CFO, okay? And transportation by animals. So in case you use horse or donkey or maybe elephant to drag the log around, that one doesn't count as a, not the hardcore man. So this is the type of the spreadsheet that you need to do. Okay, you create the process, right? So like remove the shell, right? And then there's like some materials coming in, and then resource coming in, and then waste coming out, and then product, right? And that's the product from step 1, send step 2, and what are the input for step 2, right? There's more resources putting in step 2, and then you get the products coming out, you get the byproducts coming out that way, okay? So we create this kind of thing for your whole manufacturing process. And then we can calculate this thing, right? Make the, like what the, call it inventory, right? Inventory. So like what the instructor said the other day, right? Inventory is like the hardest one to accomplish for SEMA Pro. Data required for extraction, so it's called extraction prediction of, this one is repeated on two different sources. This one from my waste management, transportation. I think this one is skipped. This one is similar. Okay. Then, in a way that we can collect data, there is some kind of set procedure for certain type of product. Okay, that one is called product category rules. Okay, so the PCR provide a standardized test, a standardized set of rules, requirements, or guidelines for calculating the carbon footprints of products for certain categories. Okay, there will be PCR for various categories. You can look it up. And then if there's one for your category products, you must follow the PCR, okay? Because they already set. If you don't find a PCR of your products, then you can set a new one, and then everybody follow you, right? But if there are existing PCR for your type of product, you must follow that category PCR. Because they make sure that the methods that you use to calculate is uniform among all the products of different company, okay? So that you can make a comparison between your product and product from another company, okay? And there is, I think this is the last video about PCR. This one. Oh, there's a two left.
Are you a buyer or a specifier? How do you compare different products? Is it hard to sort through the clutter of product and manufacturer claims as they all say they are the best? It can be like comparing apples to oranges. There's a better way. UL, Underwriters Laboratories, creates product category rules, also known as PCRs, that make it easier to consistently evaluate products' environmental impacts. This gives the common approach you need for an apples-to-apples comparison. In essence, it levels the playing field. A PCR is a set of rules, requirements, and guidelines following internationally established protocols to develop environmental product declarations. A Type 3 independently verified eco-label for one or more product categories. That means that every product in a given industry can have its environmental impacts evaluated in a clear, consistent, and transparent way, allowing you to make a more informed decision. To create a PCR, you must select a program operator and establish a committee, primarily consisting of participants from the industry. Definitions, environmental criteria based on the science of life cycle assessment, and testing methods are created through an exhaustive process and must have consensus. The PCR draft is then opened for a 30-day public consultation period for any interested parties to recommend changes, followed by a thorough review by an independent expert review panel. After all comments are addressed, the PCR is reviewed a final time by the third-party review panel and then published. UL is pleased to announce the publication of the very first global PCR, specifically for the hand dryer industry. This global PCR brings hand dryer manufacturers worldwide into the new age of transparency to evaluate the environmental impact of hand dryers with a common approach. And that means less confusion in the marketplace. So before you buy or specify, make sure you're comparing apples to apples. Learn more at buff.ly/29K530E.
Okay, so before they publish the PCR, go through a lot of process, right? So if there is an existing PCR, you must follow the protocol when you try to evaluate the carbon footprint of your product, if it fits the category, okay? Rain again, so we don't need to leave. So the key feature PCR, I think we already mentioned that. Then PCR is in ISO 14025, ISO International Standard Organization. Okay, so it's create the Type 3 environmental declarations. Okay, the benefit. Skip that. Okay. Step number 4, this is the important one for our calculation. Select emission factors, okay? So what is emission factor? This will be the last video, I promise, because it's the last one on the list. So what are emission factors? Let's watch the video. Well, the content may be on the exam, okay? It won't be all calculation. Because you need to know your stuff too, not just like crank in some Excel sheet. What are emission factors?
Emission factors are representative values that quantify the environmental impact of different products and processes. They are a crucial part of calculating the carbon footprint. Different greenhouse gases have different global warming potentials. In order to account for all the main greenhouse gases in our calculations, emissions are generally
See, this one has the same greenhouse gas potential as I use. See, so mine is agree with him.
In our calculations, emissions are generally converted to a unit known as carbon dioxide equivalents, which takes carbon dioxide as a base unit and includes the impact of all the other greenhouse gases and their relative global warming effects. Emission factors are generally expressed as the weight of emitted carbon dioxide equivalents divided by a reference unit, such as the weight, volume, distance, duration, a financial unit, or even a custom unit.
So usually the denominator will be your functional unit. Okay. So once you decide what's your functional unit, everything will be. Oh no, this will be the unit that they use that they publish in the database. So it varies from different type of products or emissions.
Unique to the scenario. Emission factors form the baseline for all carbon footprint calculations. They provide an estimate for the environmental impact of raw materials and other activities that a company may not be able to calculate for themselves. For example, while a company manufacturing plastic toys already knows how much plastic is used and how it's processed, it would likely use an emission factor for the plastic to calculate the emissions per toy. The product's emissions are calculated by multiplying the emission factor with the activity data, which means it's not possible to calculate the carbon footprint based on the emission factor alone.
Okay, so the emission factor that we get, right, is per kilogram of plastic. And then how many plastic that we go through each day, or per piece of toy, because a functional unit is one piece of Lego block. Then you get the emission of the for that product for one functional unit. Okay, so this is what we will do. Okay?
The plastic toy manufacturer would also need to provide activity data of the production process. Hence, it's important to understand that an emission factor is an estimation based on calculations using data and assumptions from studies. In some cases, the numbers represent the market average and will be different from the plastic our toy manufacturer actually uses. For this reason, replacing emission factors with primary data will improve the accuracy of carbon footprints.
Okay, so he mentioned something like that. If you use secondary data, for example, the market average, instead of primary data, then your data is not accurate. And then usually for this, if you have a choice of different things, you have to go for the one that gives out the most emission. That's the protocol, right? If you have three different emission of similar things, then you need to use the largest value for your calculation, unless you have primary data. Okay.
Using primary data means that the calculated emissions are specific to the product or activity. For a toy company, primary data would be the specific emissions from the exact plastic manufacturer that supplies the plastic used to produce the toys. Emission factors are necessarily conservative estimates because they account for all the variations within a category. Therefore, using primary data will often result in a smaller carbon footprint. Every little bit of primary data that can be included in your calculations will provide a more accurate estimate. This is a process and can be done emission factor by emission factor. But the more primary data you get from your supply chain, the more accurate your carbon footprint baseline will be, which subsequently makes it easier to implement emission reductions. Kick off your climate action strategy now.
Okay. Kick off your climate strategy.
Are you a buyer or a specifier? How do you compare different products?
No, the one hand dryer. Oh, hand dryer. Oh, sorry. The one in the Paragon bathroom. Okay, so emission factor, he already mentioned that, right? It's a coefficient that we quantify the emission associated with specific activity, materials, or process. And it's in terms of the amount of pollutant released per unit of activity, such as kilograms of CO2 per megajoules of energy or ton of waste produced. Okay? So to calculate the global greenhouse gas emission, we multiply the activity data with emission factor. Okay? Then we get the total emission. But like he said, this is the number that comes from a database. So it's actually a secondary data. If we have the number from the actual place, so for primary data, this will be better. Okay? The type of emission factors, for example, have the emission factor for energy production, right? For electricity, from coal, from natural gas, from oil, from wind, from solar, right? Transportation, that emission factors based on type of fuel, diesel, gasoline, electric. Right? Industry, for we have emission factor for cement production, for manufacturing of certain chemicals. Right? For waste management, we have the emission factor from methane emitted from landfill. Right? So these can be looked up from a database. Where to find the emission factors, right? This EPA is the Environmental Protection Agency in the USA, have the AP42 database, okay? It's almost linked to the air pollution, okay? And the largest one that a lot of people use is IPCC, Intergovernmental Panel on Climate Change, okay? So there are a lot of emission factors across different sectors, right? For international database, there's the one from United Nations Framework on Convention on Climate Change, and EcoInvent. He mentioned that in the video, right? EcoInvent is actually a company. If you want to access the database, then you need to pay them. It's subscription based. They will keep updating the number. Maybe you ask Adnan to subscribe to EcoInvent. Or we can get the number from SEMA Pro, right? Because we gotta pay money for SEMA Pro. Or from some industry report, okay? From LCA software database, right? SEMA Pro. Or peer review publications, okay? Some people will publish paper about the emission factor or something about LCA, right? And then the last step is the calculation, okay? For the calculation, you just need to have the process flow, have something, the inventory of input, output, and then emission. Then we all calculate this, and we get the final number, okay? So the final number is just the sum of each step, right? And then get the total of CO2 equivalent from our functional unit, then you get our final number, okay? But then, the final number, okay? The carbon footprint would be displayed with 3 significant figures, okay? เลขนี้สำคัญ3ตำแหน่ง For example, 3.15 kilograms, 152 grams, okay? 3 significant figures. This is Thailand requirement, okay? So if you want to round up or something, it will go with the Thai industrial standards, number 923-2533, okay? So it's more มาตรฐานอุตสาหกรรม Thai industrial standards, right? For B2B evaluation, so business to business evaluation, you might not be able to put your number on the label, right? For example, you produce steel, but you send steel to some other factory to process it. You might not be able to put a sticker on it, right? But then you can put it on some kind of document and give it to your customer. Like, oh, this is our carbon footprint. in case that he wants to do the carbon footprint for his product. He know the carbon footprint of your raw materials, right? Because your product become their raw materials. And then for that standard, I'm actually surprised. It's actually standards. So I go search for it. 929-2533. So it came out 34 years ago, right? It's for rounding off number, but it's the common sense for us engineer, right? For example, if we want the next digit is above 5, then you go up by 1. If it's below 5, then go down, you remove it. For example, 3.142 will be rounded to 3.14, but 3.145 will become 3.15. This is normal. And for a significant digit, that means it's not 3 decimal points, okay? It's different. So 3 significant digits, that means like 3 significant numbers in it, okay? And then you round off the rest, okay? For example, 1, 2, 3, 4, 5, 6. If you want 3 significant figures, this one you round off to 3 digits. This one is below 0.5, then you give 1, 2, 3, right? And then for this one, if you want to present 2 significant figures, it'll be 1 and 2, just 2 significant figures. The 0 doesn't count. 0 doesn't count, right? So it's 0.012. If you want 3 significant digits, it will be 0.0123, okay? And that's it. Wow, see, you make good time. What? I will sigh a lot when I grade you.